Welcome back, chat. Today, we're just jumping in right now. Okay. As long as we pay really careful attention that we're doing it backward, nothing weird has to happen. Like our ordered pairs are backward as well. So check it out. I'm going to go to where y is 0, which is right here on the y-axis. And when y is 0, what x did it spit out? Boom. When y is 1, I'll go up there. And what x did it spit out? 2. And again, I'm not going to include the 4, but I'll go one more. When y was 2, Addison, what x did it spit out?
5.
Love it. These are the 3 points that we just got out of this thing. We are given completely backward, but it's really no different than graphing the other direction, except our points come out wonky. Okay, this graph is close. But this is not the whole picture. What sort of symmetry did it have? Well, geez, can we just fold that thing right over the x-axis? And I'm going to use a dash line when I do it, but it would really be solid. Just eyeballing it, do you believe that it would look about like that? Okay, as we look at this, the reason that we don't often encounter things like this is because it's not a function. It doesn't pass the vertical line test. Can you guys tell me what shape that is, though? It's a parabola. Normally our parabolas are x squared and they look like up or down, same shape. This one, it's y squared, so all it does is change the axis that we're looking at, but it's still a parabola. Just like we use the symmetry to graph a parabola about its line of symmetry when you just reflect half the points, we can do it here. We can do it in a bunch of different ways. This is just one example of it. Might it save you time when you're graphing by hand? Yeah. Is it guaranteed to save you time? Probably not. It depends on the person. Do we need to do another one like this, or should we kick forward one more? Kick forward it is. All right. So that thing is not a function because it doesn't pass a vertical line test. You know what else isn't a function? There's lots of things that aren't functions, right? But circles also are not functions. Everybody know what a circle is? Okay, here's a challenge for you. You get 30 seconds. Talk with your neighbors. I want you to define a circle for me. You can't say it's a shape like this. You can't do that. I just drew some sides. I couldn't draw infinity of them. But I could draw a bunch of things that go in and out, and I could just do infinitely many of them. I don't know if it'd be a circle still. So I don't know if I'd say infinite sides. Just because I heard that language from like everywhere, because that's natural. What's a circle? There's one side. There's not really any sides, because sides are straight, and there's no straight lines in a circle. Unless you draw segments somewhere inside the circle. Any important segments that you might draw inside of a circle? Diameter or radius. Is the radius the same everywhere? So if you pick a point, I don't care which point it is, and you don't have to draw this yet, we'll refine it, and I say, hey, only go this far away. Is this point that far away? Could I do the same thing like here if I wanted? And all infinitely many spaces between here. And eventually I get all these points that are the same distance away from a particular center point, and when I connect them, what does it look like? The collection of all the points that are equidistant from some center. That's all we define it as. Now, in a textbook, you'll probably see the word locus, which is fancy. We'll define this here in a second. Locus is just the collection. So we get to talk a little bit about circles. And it's nice to see that, hey, all we have to do is set a distance and then build all infinitely many points that are that far from it, and you're inevitably going to wind up with a circle. Don't have to talk about sides, you don't have to talk about degrees, none of that. So, last little section, circles. Okay, formally, I am going to use that word the locus, not locust, like grasshoppers, but the locus, just a big collection. Locus of points equidistant from center. That's it. All of them. All infinity. Now, When you look at circles in geometry, you care about a few things. You care about the chords, you care about the tangent lines and all that stuff. You probably remember some of those words. You might not remember the full concept, but that's okay. But very seldomly, in geometry especially, did we ever have to deal with circles on the coordinate plane. There might have been one day where we did it. So here's my next challenge, or question, I guess. Did you guys see circles last year in Algebra 2? Conic sections. Did you talk about parabolas and ellipses and the focuses of such?
Yes.
Interesting that I got yes and no from that. Okay, we're going to pretend like it's just a straight no, even if you've seen it. So check it out. Turns out that if we imagine some circle living on the coordinate plane, where would you pick the center to be? The origin would be the nicest. So you can spend a moment. I'm going to get me a circle whose center is at the origin. You guys can do the same if you want to try to draw one. Because circles and nice notes are kind of irritating sometimes. All right, so I'm going to go ahead and try to draw my nice circle. Gosh, it's good. Here we are. Now, we're going to agree on a few little things. We are going to use the same letters every single time when we're talking about this, and we'll see these letters show up elsewhere also. Okay, this is the center of this particular circle. Now, it's at the origin currently, but it doesn't really matter if it's at the origin. Before I go, do we need a little bit of time to let people finish drawing their circles?
Maybe.
Okay. All right. We are going to be in agreement that whether it's at the origin or not, the center, we're just going to refer to as this lovely point, H, comma, K. Some ordered pair is my circle, as the center of my circle. There's only one other thing that I need to define this circle. It's all the points that are what from here? Equidistant from here. And what do we call the distance from this point in the middle to any point on the outside of it? The radius. I'm going to arbitrarily draw it down to here. We'll label this R. Okay. Now, center HK, radius R. Now, there are infinitely many points plotted to make this circle. If I randomly pick one of them, this one, and all of them will have the same kind of basic idea, but do you agree that this point will have an x coordinate? And it would be positive x, and it'll also have a y. Now, it would be a negative y, but if we just say in general it's x, y, and we say it could be positive or negative, every point along the circle would have that same format. Cool there. All right, so let's get kind of crazy. X, y, this point is on the circle. That's the language we're going to use. This point, don't draw this one. Is this on the circle anymore? Where is it? In the circle. There's our distinguishing language. On means literally on the circumference. So let's check it out. If I wanted to start working out some of this, based on just these two general points, could you find me the radius? And let me rephrase that. Could you find me the distance from this center, this ordered pair at the center, to this point on the circle? The distance between 2 points. How? Oh, let's use the distance formula real quick. Now, you may not have it locked in and memorized yet. That's okay. It's the square root of a couple things. Let's do the x's first. How do you find the distance between h and this point in the x direction? Or what does the distance formula look like? So it could be h minus x or it could be x minus h, right? By convention, and we'll see that we'll just use this, I'm going to use x minus h, and what must happen with it? Squared. What must I add to this? Y minus k squared. This is the distance formula. Everybody cool here?
Yeah.
Anybody love radicals inside of your expressions? Right? Like, it'd be cooler if there weren't a radical symbol here. Well, gosh darn it, Dolan. How do I get rid of a radical symbol? What undoes a radical? So, what side should I square? Good answer. I'm going to square both sides, only to get rid of the radical because it's going to look nicer. So we'll square both sides. If I do that to the left, I get r squared. And if I do that to the left, I just get rid of the radical symbol. Have I done anything crazy yet? Does it feel like we're done? This idea here, I want you to draw a big old star next to it. This right here literally is, and I'm going to draw an arrow going up to it as well to really draw attention. This is the equation of a circle. That's it. If you can do the distance formula, you can do all the mathematics associated with circles. Okay, we're going to add a couple more little things to this because there's additional little pieces that we want to make sure we highlight. This is the equation of a very specific circle. This is the equation of a circle with center at which point? So it is, but there's no numbers, so maybe I just did a weird job. Love that. HK. The center is at HK, and the radius is what? R. We're done. That's it. If you give me a center and a radius, or a center and a point on the circle, I can find the radius, and I can write the equation of the circle. Let's try one here. So, we're going to do two examples. I'm going to give you an easy one. We're going to do a harder one together first. Cool. Christina, I'm super thirsty. Will you give me a drink real quick? Thank you. No, I just need you to go get a drink and I'll feel parched, or I won't be parched anymore. All right. Right equation. Okay. I want a lovely circle. Basil, what's your favorite ordered pair that's not the origin?
2, 6.
Love it. But we're going to make it a -6. The center of the circle is going to be at the ordered pair 2, -6. And the radius, red, radius, ours. What's the radius? 7. Love it. Okay. Here's where we're going to go. We're going to do do a lot of your teachers do the watch me do it, now we all do it, now you do it? So teacher talk, that's called I do, we do, you do. I try really hard to not make you guys do a whole lot of the I do part because I think you can watch somebody else do math, like that's whatever. We're all going to do this problem together first. If you ever feel like it's just me talking, like it's just me doing it and you guys are watching, please stop me. I don't want it to be that way. All right, should we do a few quick burpees before the problem or just jump right in?
Just jump right in.
Okay. God, this guy. In this equation, because I know this is what it's going to wind up to, do we know the radius for this circle? So right underneath, I'm just going to make sense. What's R? It is a radius. Very specifically, what is R?
7.
Oh, it's 7. It's already written here. It's going to be redundant, but we'll try it. R equals 7. Okay. Do we know the center? And Basil, what ordered pair do we use in general to represent the center of a circle? So careful. What did we write up here for the center? Even if it's at 0, 0. More general than that.
Oh, H.
Love it. H, K. Do we know what H and K are for this particular problem?
Yes.
What?
2 and -6.
2 and -6. This is literally all of the information that we could possibly need. In this equation, is there a place that I can plug in R?
Yes.
Is there a place that I can plug in H and K?
Yes.
Is there anywhere, do we write down an X and a Y to plug in up here? We haven't. We're not going to change them. They're going to stay as they are here. So let's just see if we can do this. When I jump in, I know that it's this formula, R squared, and all the rest. So I just need your help a little bit. If R is 7, what's R squared? 49 equals X minus, what's H? So I heard 2 and I heard -6. Which one's correct?
2.
2. The -6 will show up. What do you think is really common people forget to do with this set of parentheses? Yep, Leigh said it right away, the square. X minus H, or 2 in this case, squared, plus, there's another really common mistake that happens when I put in this next number. It turns into a +6 because minus the negative. Was that crazy difficult? We're done. This is the equation of that circle. we're going to graph it as well. I'm not going to make you graph the next one, and you're not going to graph it like perfectly, but I want to show you there is an easy way to graph these. So, do I really want to go 7? Sure. Okay, I won't make you graph the next one. I'll graph it, I'm at the bottom, I'll graph it right here. Okay, so looking at this, I know that the center's at 2, -6. Bless you. And I'm not going to go crazy with my scale. I'm going to eyeball it, okay? 5, -5, and we'll go 5 and -5. I don't really think I need to go that far, but I just want a rough scale on mine. I want you guys to help me roughly eyeball the point 2, -6, because I'm going to place my center first. We'll do it in blue. Is that 2-ish? Okay, and then would you believe if I said there's 2, -6? Okay. Once we get to the center, we're like the hard part's done. It's going to look like we're going to graph a square. We're not. Okay, what's my radius? Okay, is it really easy to count 7 diagonally? Not really, right? Because if you go up 1 and over 1, you've gone √2. That 7 is not a nice number to go diagonally. Are there directions that are easy to count? Up, down. Can I go left and right pretty easily? Hey, let's do that. If this is my center, I'm going to go up 7. Now it's at 1, because I went up 7. I'm going to go right 7. I'm going to go down 7, and I'm just eyeballing this now. I'm going to go left 7. You can tell my scale is not perfect, but that's okay. Here's my center. What does it look like we're going to graph? So I hope so. To me, it looks like we're about to graph a square. The only reason we do these is because those diagonal distances are not easy to calculate. However, if I know that this is a quarter of a circle, can I make a quarter of a circle? Once, twice, thrice, and 4 times. And look at that. We have a lovely, okay circle right in front of us. Just need the center, just need the radius. Okay. I'm going to give you guys a second. I'm trying to decide if I want to give you another example to do here together, or if we just want to throw it on the practice homework. Okay. We'll put it on the homework. I'm cool with that. We won't do another example right now because I'll let you guys play with it, but we do have to talk a little bit more. I could present this information in like a bunch of different ways. If I gave you a diameter, and I said the diameter, and no more writing unless you really want to, but I'm just going to get some graph paper here, and we'll just talk a little bit and see if we can agree on some maybe good, easy ideas to make stuff go a little quicker for us. All right, I gave you the center and the radius, and you could do it. It's easy, right? If I wanted to just be a jerk, or I wanted you to think a little bit harder about it, could I just say, hey, this point and this point are on a diameter? If I said this segment is the diameter, you think you could still find the equation of that circle? So I'm going to spoil it. We can. Here's my question for you. If this is a diameter, how would we get from here to the equation of a circle? Talk it out. We'll give it about a minute. I'm going to hope for ideas. Good, bad. Oh, this is the center of my circle, also known as the midpoint of any diameter. Do you guys know how to find midpoints? Well, that's pretty handy. So let's say we had this center then. Then what? We have HK. Good. What else would we need? How on earth would you find the radius? Like it's here, but what? That's a weird curly bracket. It's here. But how would you actually find that length if I gave you that point also? It's the distance formula, and you could get the radius. You would then have the center and the radius. Do you need anything else? That is it. Okay, so we have about 18 minutes to start in class. How long outside of class should you work on homework? So we're going to split the difference. We're going to go 45. You guys are juniors. I don't think the assignments will usually take you 45. Today's assignment is kind of long. What'd you get? almost 20 minutes in class. So, remember, in class, have we had homework in here yet?
Yeah.
Okay, so I'm not going to go over that. I do have homework to hand back to you. I just couldn't remember if with this class had it. So let's find this, and I'll go ahead and post it in here. If you're not in the Google Classroom yet, do it. Okay, so today is the 26th of August. Nope, you're not bold. 8/26. This is Precalc. Lesson, what? Cackle. Finish, I'm just going to say circles, because we did more than that, but circles, we're just including all of this. Did we finish everything? I think we did. Yeah, we finished. All right. We'll post the video afterward. Here is your lovely homework. We'll call this homework 1.2, which you will find waiting for you on page 19. Okay, we'll pretty much always have vocab, just so you guys are aware. Vocab will be your 1 through 6. And beyond this, how much graphing do we need to do?
Just a little.
Okay. I want 9 and 11. 9, 11, 17, 22. They're all going to be random numbers. 45, 52, 54, and we got a couple more. 70 and 75. So it seems like a lot. It's not some of that, like you might finish before you leave if you start right now. Cool. We'll get some tunes going. Stay on task. My hope is that you don't have homework tonight.
I love that.
You may. Thank you for waiting until the end. All right. This, like always, is due tomorrow, so we'll
No,
say,
just sign up.
yeah, still sign out. But I won't take points. Baller. Cool. I'll let you guys get started. If you want to keep the circle things, you can, but I don't have thousands of them, so if you lose it, I might not give you another one. Cool. All right. Do it to it. I'm going to post a video too.